Welcome back to an introductory course on ground support equipment. So moving towards the end of this section, in this lecture, we will learn about the aircraft de-icing equipment. We will start with an introduction to the equipment, why is it needed, then we will take a look at how de-icing operation takes place at an airport, followed by discussing various de-icing fluids and methods, and finally concluding this lecture by discussing the difference between de-icing and anti-icing. De-icing is a common practice in the industry which involves automobiles, railways, and aviation. De-icing provides protection against ice buildup and snow contamination of critical control surfaces, engine inlets, and sensors on an aircraft prior to takeoff. There are hundreds of cities across the world which experience sub-zero temperatures every year. In engineering, diesel engines are fitted with heating coils within the engine to prevent startup problems in extremely cold areas. Similarly, these extreme cold weathers bring a lot of challenges in the aviation industry. Now, as the ice has quite unavoidable relationship with the aircraft, it has a severe dangerous effect on an aircraft. An aircraft is usually designed aerodynamically so that air flows evenly over its surfaces without any disturbances. Ice mostly affects the wings of the aircraft. Their aerofoil shape is extremely optimized and designed for excellent aerodynamic properties. The biggest problem here is that ice deposits on the wing change the shape and disturb the aerodynamics of the aircraft, and it is dangerous enough to cause aircraft accidents. This is why de-icing equipment is very important for airports located in extreme weather conditions. So let us discuss the concept of de-icing. Before the takeoff of an aircraft, this specialized equipment known as de-icing truck sprays a hot fluid over the aircraft body. The temperature range of the hotness is between 60 to 80 degrees Celsius. This fluid melts and removes the layer of the ice formed over the surface of the aircraft. Well, pre-treatment and post-treatment inspections are carried out to make sure that the aircraft is ready to fly. This de-icing fluid is similar to automobile coolant and antifreeze liquids. These liquids have lower freezing point than water. This is why when they are sprayed over the metal bodies of an aircraft, it does not freeze in sub-zero temperatures. These fluids typically consist of glycol water solutions containing a dye and an agent to protect the metal surfaces. Thickeners are also used to make the fluid adhere to the airplane body. Ethylene glycol and propylene glycol are the primary ingredients of de-icing fluids. However, propylene glycol is most common because it is less toxic than ethylene glycol. EG fluids are still in use of aircraft de-icing in some parts of the world because it has lower operational use temperature than propylene glycol. De-icing can be accomplished by various methods such as mechanical methods, for example scraping or pushing, through the application of heat, by the use of dry or liquid chemicals designed to lower the freezing point of water, or by the combination of any of these different techniques. Now these de-icing fluids are internationally standardized by SAE International. It has classified the fluids into four types, namely type 1, 2, 3 and 4. Type 1 is called the de-icing fluid while the other three are called anti-icing fluids. So we have known till now that de-icing fluids are heated glycol diluted with water for de-icing and snow or frost removal. Then what are anti-icing fluids? Well, they are unheated, undiluted propylene glycol based fluids used to retard the future development of the ice or to prevent falling snow or sleet from accumulating. So, to understand the difference between them, let us first understand the concept of hold over time. It is that how long does a fluid remains over the aircraft body which is being used for treating icing on the aircraft. This holdover time depends on its chemical makeup and viscosity plays an important role over here. The de-icing fluids have a shorter holdover time. They melt and remove the layer of the ice which is already formed on the aircraft body. Whereas anti-icing fluids are so called because they have longer holdover time. So when they are sprayed over the aircraft body, they remain for a longer time than de-icing fluids and prevent water from icing over the aircraft. And due to the viscous nature of these fluids, de-icing fluids are also known as Newtonian fluids and anti-icing fluids are also known as non-Newtonian fluids. These de-icing fluids and anti-icing fluids can easily be distinguished by their color. Type 1 fluids are orange in color, type 2 are colorless, whereas type 3 are yellow in color and type 4 are green in color. The viscosity of these fluids increases as we go down from type 1 to type 4. Now, just as the catering truck, the de-icing truck has a truck chassis. It houses all of its systems over the chassis. It has fluid tanks with separate compartments for de-icing and anti-icing fluids. These compartments are fitted with heaters to raise the temperature of the fluids. Above the tanks, there are hydraulic booms and bucket systems to allow the operator to reach different areas and heights of the aircraft. This truck has all the necessary hoses and pumps which are powered by the truck's engine, which allow the operator to spray the fluid. So let us differentiate between de-icing and anti-icing. De-icing is the process of removing snow, ice or frost from the surfaces, whereas anti-icing is understood to be the application of chemicals that not only de-ice but also remain on the surface and continue to delay the reformation of the ice for a certain period. On the ground, when there are freezing conditions and precipitations, de-icing an aircraft is commonly practiced. De-icing needs more pressure than anti-icing because intention of de-icing is to remove the ice which is already formed over the aircraft body. When the ice is removed, the anti-icing fluid is sprayed over the aircraft such that it forms a protective layer over the aircraft to prevent icing again till the time the aircraft is on the ground. So this was it for de-icing and anti-icing trucks. See you all in the next lecture.